So let's start. Yeah, guys. So today we are going to actually have the class on one of the very important concept. Okay, that is something called as networking. Okay, so today we are going to have the class on networking. Okay, this is a very important topic because our further future topics are actually going to be dependent on this particular topic, that is networking. So, what is the first thing that come into our mind when we talk about networking, right? So, whenever two device wants to communicate with each other, they always need some kind of a physical connectivity. Okay, so this is device A and device B, and whenever two devices want to communicate with each other, we always need some kind of a physical connectivity, okay, so that they can actually talk to each other, and that connectivity could be either wired or it could also be wireless. Okay, it could be wired or wireless, right? So in your college days you must have heard about the term topologies, right? So this is one of the network topologies, right? You might have heard about the term network topologies, right? So network topologies means way of organizing your devices. Okay, way of organizing your intermittent devices so that devices can communicate with each other. So there were different network topologies that you might have studied in your college days or in your schools or anything. Okay, in your networking chapters and all. Okay, so you might have heard about this topic, but you might not know that whenever even you using the internet in your home, you are actually using the multiple network topologies also in your home as well. Okay, so when we talk about the networking, right? So say we have a device one and device two. So if we take a Ethernet wire and try to connect the both the end of the laptop. Okay, so this is also called say device A or device B. If we take a wire and connect to the two end, okay, it actually make one private network of yours. Okay, so this is your own private network. That means when you took two devices and you connect them through a Ethernet cable, okay, you actually establish your own private network. So this is the reason. This is the reason why your companies like Amazon, Google, and all, okay, they have established their own private network all across the world. That means this is not internet. Okay, this is your own private network. Okay, this is not internet, this is your own private network. That means even if in our home, if I take two devices, that means two laptops, and if I take an Ethernet cable and if I connect with the two Ethernet cable, okay, you can actually establish the connectivity between two of your laptop, and whatever the data transfer that you basically want to do, okay, between these two devices, it will be very fast. Why? Because you have a dedicated line connected with each other. So whatever the data transfer that you want to do between these two devices will be very fast. Okay. So because this is your own private network, right? So in the same way, you there is companies like Amazon. Okay, companies like Amazon, Google, Microsoft, okay, they have actually established their big data centers. Big data centers too, I mean that they have actually taken the real physical land all across the globe. Okay, and they have established the servers over there, and each of the multiple servers are connected with multiple intermittent devices. Okay, and Amazon and company like they have actually established their own private network all across the world. Okay, so you might know that in Azure, so if they have to actually transfer the data, you can think they have actually set up their own bigger, whatever you are seeing this in this particular diagram is a very, I can say, minute part of the private networking. But companies like Amazon, Google, when they have taken their own data centers, and each of the data centers are privately connected by the high fiber optic cables. Okay, and each of these cables are undergoes through your oceans, seas, and they are connected to multiple different continents all across the world. Let me show you one of the example of the private networking. Okay, so as your global network infrastructure. Okay, as well global network map. You see, you can see over here, right? That Azure have actually set up uh, some kind of their own private global network all across the world. Okay, one
Arpit, we see your screen.
sorry. You can't see my
We
screen?
can't see the screen.
Oh, okay. But me, I think my screen is not visible. Thanks for pointing it out. Yeah. Okay. I think you might have missed some points. Okay. I'm really sorry for that. So I was saying, what is networking? Okay. We have two devices, that is device A and device B. Whenever device A wants to talk with device B, we always need some kind of a medium or some kind of a physical connectivity between these two devices, that is device A, that is device A and device B, so that they can actually talk to each other. Okay, and that medium could be either wired or it could be wireless, depending upon the type of connectivity that you have chosen to connect your two devices, or two laptops, or two PCs, or two smartphones. Okay, so in your college days you might have heard about the term called network topologies. The meaning of the topologies is nothing but, the meaning of topologies is that how you actually design your network. Okay, in what way your communication within your multiple devices that you are trying to design, so that multiple devices can actually talk to each other. This design itself is called as a topology. Okay, I think in your college days you might have heard about the single topology, right? Single topology, where if you take two devices, that is device A and device B, and if you connect the both the end of that particular devices with the high fiber optic cable, that is your Ethernet cable. Okay, so automatically you establish a private connectivity between your device A and device B. This is not your internet, this is your private network, and the data transfer between both of these particular devices is very fast. Okay, very fast. It is super duper fast. It is, I think, according to the speed of light, the data transfer will happen. Okay, so that is the reason why companies like Google, Amazon, Microsoft, they have established their own private network all across the world, I can say. Okay, by all across the continent, within multiple geographical regions, they have actually taken the real physical land. Okay, they have actually taken the real physical land. I think in the diagram you can see, that is the diagram that I wanted to show you. Okay, you see all across the world they have taken whatever these blue things that you are actually seeing over here, right? Whatever this blue thing that you see, okay, these are your real physical data center, right? These are your uh, real physical data centers, whatever the things that you see in the blue diagram, right? This is your real physical data center of the Amazon, of the, sorry, of the Microsoft, right? It is, you can see it is actually spread all across the world. You can think they have actually, they are actually covering the whole unit region. This is not internet, guys. Again, I'm telling you, don't get confused with internet. I will tell what is an internet. This is the whole private network where they are establishing their multiple data centers. Data centers are nothing. It's a real physical land. Okay, it's a real physical land where they have actually set up their own computers, and each of the computers are having their own compute resources, that is their RAM, CPU, and hard disk. Okay, RAM, CPU, and hard disk. And each of these particular data centers are actually connected with these high fiber optic cables. Okay, these are actually connected with your high fiber optic cables. And all these cables are actually going under the sea, oceans, and beds. Okay, so whatever this particular part that you see, these are the oceanic part. That is, water bodies are there. That is your sea and all. And all these wires are actually going inside this particular wire and are connected to the data centers, which is spread across the different component. Okay, so you that is the reason why Azure and Amazon say, guys, that if you basically want to transfer your data, we have our own private data network, because we cannot rely on internet. When we talk about internet, you know what is happening is, since all these devices belongs to the same company. Okay, these devices belong to the same company, and no any external network has the connectivity within this particular network. Okay, so data transfer between these devices will be very fast, because whatever the speed of that particular device that will be there, no, that will be equivalent. Okay, that means me whatever the speed, whatever the amount of speed this device can actually transmit or send the data or receive the data is equivalent to whatever the data it can receive and send back to the other data centers. Why? Because they're connected with the dedicated lines. And you know, generally whatever data transfer that you do wireless, in that case what happens, some of your data also get lost. But in the wired connection, you can think, when you talk about a wired, right, in a very layman terms, when you talk about a wire, right, these are the two ends, so there is no space that that whenever the data is actually getting transferred between two devices. Okay, so your a signal or energy get a digital signal get created, that is 0 and 1, right? Computer only understand these two language, that is 0 and 1. So whatever is this data that actually goes, it converts in from the digital signal to analog signal, and this signal travel with the speed of light to the other devices. Since there is no opening only to the outside, that this data can get lost, right? So that is the reason the data lost is completely almost zero when we talk about the dedicated line. You can think this is a pipe. Okay, from one end when you send one thing, there is no space for the device to go out. Means there is no space or there is no leakage that is happening within this particular wire, that your data will get lost, right? So that is the reason why dedicated lines are always wired. That is the reason why in your home also, that is the reason why when you want to transfer any, you might see that if you are working in Azure or AWS cloud or anywhere, when your data has to be transferred globally, okay, if they are using private endpoints or private networking, you will see the data speed will be very fast. And when they are using the public internet, okay, that is public internet, okay, which is a collection of a different kind of a network, okay, the speed of the data will be very slow. Or it might I can say it is a very ad hoc manner. Sometimes it is quite fast, sometimes it is low, sometimes it is very fast. There's no complete means if you plot them in a graph, you will see the data transfers are very irrelevant. It will not be like it is a consistent gradually increasing kind of thing, right? So now when we talk about the internet, right, so when we talk about the internet, so what is an internet? Similarly, this is the multiple network connected with multiple devices. So this is one of the network. Okay, and all of these networks are private in nature because there is no connection with the other network of the all across the world. Now, when we talk about the internet, okay, when we talk about the internet, what is an inter? Does anyone have any question till now before moving to what is internet? Sneha, do you have any question in this?
No.
Okay. So this is also one kind of topologies that is happening. This is, you can think it's a kind of a mesh topology. Mesh topology. Mesh topology in the means each of the devices are connected with each other. So it's a kind of a mess, right? It's happening actually a kind of a mess kind of thing. Very, it's look very messy, right? Normally you can see there are too many wires and all. That is the reason it is also called as kind of a mesh topology. Okay. Now, when we talk about internet, so what is an internet? So, guys, when we talk about the internet, internet is also called as a public network. Okay. So, internet, what is an internet? So, what do you understand by the term internet? So, when you hear this term internet, what is an internet? Internet is nothing but it is a different kind of collection of different kind of networks, different kind of network, or you can say different collection of the different types of network belonging to multiple other companies together makes an internet. You can think if you go, you can think world, you are going in a room, okay, and you see, suppose there is a spider in your home. What does spider do? It actually leaves a web in your home, right? What if the spider leave multiple webs all across your home? Okay, so it is a collection of a different type of webs, right? So zip 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 zip, if the spider is doing, it will look so much messy. It's a collection of different kind of webs or different kind of network. So that is what internet is actually called. It is a collection of different kind of a network. Okay, sometimes it is also known as public network. Why? Because anyone from the outside world can directly connect with many other people and many other organization, companies, bodies, etc. Right? And when we talk about the public internet, there are a lot of companies whose devices are there. Maybe Amazon can connect to Google, Google connect to Geo, Wi-Fi, whatever the internet service provider that we are actually using. So internet is a collection of different kind of a network. Now, let me tell you one more thing. Okay. So the moment when I say that internet is a collection of a different kind of a network, right? Aditi and Riya, do you have any questions so far? Aditi,
No.
are you understanding what I'm
No.
trying to? Yeah. Hello. Did, did anyone have any question? Riya, do you have any questions so far?
Mm, Arpita, I am also good. Aditi here.
Yeah, yeah. Riya, so far, do you have any question?
No, nothing, Arpit.
Okay. So now when we talk about the networking, let's talk about your home networking. Okay. So what happened? Home networking. In your home networking, how multiple, when we talk about internet, when I was saying that internet is a collection of a different kind of a public networks, okay, or public network, right? So this public network itself is also private in nature, means there are multiple private networks that are there. Okay, and each of these private networks is actually connected with each other, which together forms an internet. Okay. Now, so how you guys also become a part of internet? How does your home networking, how does your home Wi-Fi that you take from your internet service provider also become a part of a particular network? That means part of this particular whole big network that is internet. Let me tell you this thing. Okay. So, suppose you actually need an internet connection at your home. So, what you say? That whenever you need an internet, what will happen? Generally, you will fall to some kind of a provider, right? Those are called as you will connect to some kind of providers, some kind of provider companies, okay, who will actually provide your internet. Provider companies who provide a service, who provide one kind of a service, okay, that is internet, kind of a service, that is internet. And these companies are also called as ISPs, that is the internet service provider, because they are providing you with one service, and that service is called internet. So the moment when you want to install an internet connection in your home, so what happened is generally you call to your ISP provider. And in India, if I talk about, we are currently sitting in India, there are two companies which are famous in providing the internet. One is the Airtel and other one is the Jio and other is the Airtel, right? So these are two famous companies who actually provide the internet. So when you call them for the internet, what actually they do is they come to your home, okay, and they establish a kind of a box in your home. And that box, sometimes, that box could be white color or black color box, which is having two antennas at the home. You know what they do, guys? Okay. So they establish a private connectivity within your home. Okay. A private connectivity within your home. Okay, so you can think this is your home, and in this home, they actually establish their own private network. Okay, and before talking about, so what happened, and this particular device, what they actually install in your home is called as a router. Okay, so this device is called as a router, or it is also called as an internet gateway. It's a gateway to the internet. It's a way from your devices within this particular network to go to the outside world and can connect to some other network. Okay, so that is the reason why router is also called as internet gateway. So what happening is, so whatever this box that you see, they come and actually install a particular white box in your home. And this particular white box is connected with some other kind of a other devices outside of there, that call is some kind of S box they call them. Okay, you can think they actually install a router at your home. Okay, now before going to the router, let us try to understand what is a before understanding this particular big network, let us go and try to understand what is an IP address. Let us take about a simple example of two devices who wants to go to internet. Okay, so let me just make it more clear over here. Okay, so normally, currently in your home, you might be having multiple devices, right? You might be having your mobile, you might be having your smart TV, you might be having your laptops, or you might be having some other your dad's laptop, your mom's laptop, or your mom's wife, your mom's mobile and all. And each of these devices wants to connect with the internet, right? They want to connect with a one big network, that is your internet, which is a public network, which is a public network. So what is happening? Whenever two device want to go to the internet, Okay, or whenever two devices want to connect with each other, there are few things that we need to keep in mind. First, the device should have an operating system that is actually running on top of it. Second, you also need some kind of a address of that particular device, right? Some kind of a medium or some kind of a address of that device, right? Even a human also has some kind of a address. Otherwise, how will someone know address of that particular device? Right? Otherwise, how will someone know? That means suppose, and this address is actually called as an IP address. Okay. And this IP address never get assigned to your device. This IP address always gets assigned to a NIC card. It's a real physical card within your laptop. It is sometimes it is also called as a NIC card. Sometimes it is also called as an Ethernet card, or sometimes it is also called as a LAN card. Okay, if you open your laptop, there will be a device in your laptop. Okay, this device is also called as a NIC card actually. Okay, and whatever the private IP that gets assigned by your internet service, whatever the IP, let's call it the term private, and whatever the IP address that actually get assigned to your particular device, okay, is always assigned to this particular NIC card. So if I remove this particular card from your device, no, your device will never be able to connect with your with any kind of a network, whether it is an internet or a private network. Okay. And the third thing that you need to understand is what kind of IP you want to connect to, whether it is a private IP or it is a public IP. Okay. Normally, you are actually having two types of IPs in the market. And before understanding what is a private IP and public IP, let us understand what is an IP address first. Okay. I hope this is clear to everyone so far. Even in your laptop or even in your mobile also, when you are running an Android operating system, or you are running with the iOS operating system, so you always need some kind of a operating system, and each of the devices also has their own resources that is actually running inside, and each of the devices has their own NIC card. Okay, and each of the IPs that actually get assigned to this particular NIC card. Even in my laptop also, I'm actually having a NIC card. Because of that reason only, I'm able to see the IP address of my laptop. Okay, so you see, this is the IP address of my laptop. Okay, this laptop has this particular IP address. Okay, now taking an example of my laptop first, let's try to understand what is a IP address and how does this particular IP address actually get assigned to our devices. Is it sounding something typical to you, something that you are not aware of, guys? Mhm. Please let me know. Hello, audible? Aditi or Sneha or Ria, something that you are not understanding? Hello.
No, I'm good.
Yeah. So the moment when we talk about IP address, what is an IP address? Okay, let's talk about the IP address first. Okay, this IP address. So in your computer, I told you one thing, that your computer only understands two languages. That is one or zero. That is also called your binary language. Other than this, it doesn't understand any other language. Okay, so whatever this IP address, so any number that is there within the range of 0 to 255, 0 to 255, or 0 to 255, or 0 to 55 is called a valid IP address. Okay, and each of the block that you see, each of the block that you are actually seeing, that means if you try to assign 257, you'll never see an IP address that start with 257. You'll never see any number of the first block itself which is actually having 257, because any number that is always there within the range of 0 to 255 are the only number who can be your IP address. Other than this number from 0 to 255, there cannot be any number which can be your IP address. Okay, so each of this particular IP address that you see currently, this 192 is also within the range of 0 to 255, correct? And this 168 is also within the range of 0 to 55. This is also within the range of 0 to 255, and this is also range of within 250. And each of the number that you see, okay, this particular block is also called one byte. Okay, this is called one byte of a one byte. where 1 byte is equal to 8 bits. Okay, 8 bits. That means total of 4 bytes together make a valid IP address. Any number which can actually be stored in 4 bytes or or 4 octets is a valid IP address, or 4 octet is a valid IP address. That means what happens is, in your computer, what is happening, how does your IP address get stored is, normally if you take out the binary, these numbers are also called the decimal numbers. Okay, in computer, in your hard disk or your RAM, your IP address always gets stored in the form of a binary number, not in case of a decimal number. So what happens, if you take out the decimal number of this one, it will somewhere be something like 01110 something. It will be somewhere about 8 bits. Okay, 8 bits. 11011118. If you take out the binary of this particular number, that is 192.168.24.0, it will be something like this only. Okay, this number, something like this. Okay, and if you combine this whole binary number, it's together makes something as 32 bits. Okay, it comes at 32 bits. Okay, and then what is happening is, from the okay, so if you see, if you count the total number of bits, it is actually called as a 32 bits. And how we are actually calculating out the IP address is, from the right significant bit to the last 8 numbers, we are actually putting a dot, and then we are taking out the decimal of this particular number. So if you take out the decimal of this particular bigger number, okay, it would be something of the zero something. This is just a hypothetical example. I'm just giving a dummy numbers. Okay, but if you take out the real decimal number of this zero, it would be somewhat as 8 zeros. Okay, this will be somewhat 8 zeros. Okay, I'm just giving a dummy example over here. So don't think this is the actual binary number of 24 is 11101. No. So what happened, from the complete 32 bits, from the right significant bit, that means from the right to left significant bit, total of the last first 8 bits, if we traverse from right significant bit to the least significant bit actually, okay, and then we put a dot here, and if we take out a decimal of that particular number, you will see, you will actually get back your this number, that is your first bit. And then again, from the right to left, if you go and put a dot over here, and if you take out the decimal of this particular number, you will get this particular number, 32 bit. And if you take out this particular number, and if you take out the IP address, you will get this number. And the similar way, if you take out the decimal of this particular number, you will get this number. So generally, in your system, when your computer actually store your IP address in this format, okay, it's a human, for our understanding, we have given in this, no, we are putting dots, because we cannot remember such a big number, right? If somebody asks you to remember 11010111111, that is not possible for a human. So we only understand decimal numbers. So that is the reason why we see in the system as this way, but actually your IP address are stored in this number. That means any number, that means any number, okay, any number or any number which can be stored in 4 bytes, or which can be stored in 4 bytes, or can be presented in, or can be presented in 32 bits, or 32 bits is a valid IP address. Okay, and when we talk about 1 byte, where 1 byte is equal to, 8 bits, that means 8 into 4 equals to 32 bits. Okay, so any number which can be represented in the form of a 32 bits are also called as a valid IP. Okay, so this is the reason why, how this is what the IP address is getting stored in your laptop inside your hard disk. Okay, this is how the laptop actually understands. This dot does not have any value. It's for the human understanding, we have given this IP address. Okay, if you take out the complete decimal number of this whole big number, no, okay, if you take out the decimal, it will come somewhere around 192.1156, a big decimal number, which might be little difficult for you to understand, but this is also a valid IP. So I have a question for you, that many people, I have seen many people, if we say that this number 168.24.5, as per you, this is a valid IP. But can you say, if we say like 190, 286.745678, if you know this number is also a valid IP. If I tell you, Aditi, that a bigger number can also be a valid IP, it is not necessary that every number has to be stored in the 4 byte is a valid IP. No, any bigger number can also be a valid IP. Why? Because what happens is, uh, one minute. So why? Because what happens is, whatever the 32 bits that you have, that is whatever the 01110 is there, whatever the 0132 bits numbers are there, if you take out the decimal of this entire big whole number, you will actually get a very big number. Okay, you will actually get a very big number, that is something a bigger number like 294567892 something. And if you do HTTP in your browser, if you open and download HTTP and give this whole number, this will also work. Okay, so if you take, I think I have shown this practical, I can show you this practical and prove you. In the next class, I will try to prove you that whatever I'm giving a question, guys. Okay, can you tell me, as per the industry standards, people say only the numbers which can be presented in this particular format, 10.0.0.1 is a valid IP. Okay, can you tell me if I gives this kind of a number, something as 190, 19546247892, can this number be a valid IP or not? Can anybody tell me? This is a task for you guys to find out that can this number also be a valid IP or not? Okay, can you note down this particular question? I have a question for you, for all of you, to find out with me with a solution. Okay, in the next class, I'll explain you that if this number people say is a valid IP, okay, the other number is also a valid IP. There is nothing like that. This number can only be a valid IP. It's our human, for our human understanding, we have put in this way. I have already given you the hint that why this number cannot be a valid IP. So I want, there is a question for all of you to help me in finding out,
Arpit,
this.
can you put the question on the chat? It would be easy to.
Yeah. So let me just reiterate the question. Okay. My question is, can a bigger number, can a bigger number, can a bigger number be a valid IP or not? Valid IP or not? Okay. Let us take an example of one of the IP address, 8.8.8.8. And the other example, if I take out 2957643216792. I'm just giving a dummy example. Okay. Can you tell me, can any one of you tell me, this is a question, which of these numbers are the valid IP? Okay, my question to all of you is, which of these particular numbers is a valid IP? I'm putting this question in the chat. I want you to find out the answer and also explain me the reason why. Okay. Can a bigger number can a bigger number also be a bigger number can also be a valid IP or not? Okay, first one 8.8.8. Second number is something. Second is 29, something like this. Okay, can this bigger number be also be a valid IP or not? I want you to find out the answer to this particular question to me and give me that can this bigger number can be a valid out of this both of these numbers, which of these numbers is a valid IP? Okay, Sneha, this is a question for all of you, Riya, Sneha, and Aditi. I want you to find out and tell me which of this number is a valid IP. And in the next class, if I ask, you need to tell me the reason. Okay. Just let me know if any one of you find out early. You can connect with me personally also and can give me the reason why. If not, I'll tell you in the next class why I was saying why I can tell you which of these numbers are the valid IP. Okay, as per me, this bigger number can also be a valid IP. Just prove me whether I'm right or wrong. Okay, So Aditi, I want you, Sneha and Ria to find out this question and answer me. This is a task for all of you to find out whether out of this the number, which two number could be a valid IP. Okay. Now coming back to the context, what is
Arpit, so for the first and the second one, for both of them, we have to give the justification, right?
yeah, which of this number can be a valid IP? This number obviously we know that 8.8 is a valid IP.
Correct.
We
This
just
is a Google IP, right?
so this
I
is
think this is.
a Google. This is one of the IP of the Google. Google has many
Hmm.
IPs. Okay, this is a
Yeah.
valid IP. I just want you to find out, can this number also be a valid IP or not?
Okay.
Okay, if yes, then how? If not, then why? And I want the reason from all of you. I'm going to ask this question to make it. This is a task for all of you, and come with me in by tomorrow or in the maybe somewhere in the next week when I'm going to take the class. I can explain. You just remind me to explain this concept. This is a very wow concept actually. Okay, to tell me why this bigger number can be a valid IP or not. Okay, and hope I explained you what is the meaning of a IP address. Right? I hope you understand what is an IP address. That means any number that can be stored within the range of 0 to 255, 0 to 255, okay, and 0 to 255 and 0 to 255 is a valid IP. Okay, so any number that we present in this particular, this has nothing to do with this particular question. Okay, just forget about what I'm explaining is now the next part of my class video. So any number which can be stored within the range of 0 to 255, 0 to 255, 0 to 255, 0 to 255 is a valid IP. So this is how we actually present our IP address. That is the reason if you see in my laptop, currently, this number is a valid IP address. You can see this is the IP address of my laptop. Now let us come to very general networking. Okay, suppose you have a device here and this is one of your device. Okay, now if this device actually wants to go to internet, or if this device want to go to the internet, okay, so they always have one IP address of this, you always have a IP address of this particular laptop, okay, which is assigned to your NIC card, right, or your Ethernet card, right, Ethernet card. And even this laptop will also have some kind of a IP address. Okay, that will be assigned. This IP address is also called as IPv4 address. Okay, that is version 4 address. And this 192.168 is called as IPv4 address. Okay, and suppose let us take an example. This particular laptop has an IP address of 192.168.2.1, and this IP laptop has an IP address of 192.168.1.1. Okay, now if these two device, whatever this IP, if these two devices wants to go to the internet, right? How these devices actually goes to the internet? This device is actually a different network, I can say, and this particular device is part of a different private network. Okay, and both of these device wants to connect with so both of these together also becomes a part of one of your bigger network. Okay, that is your internet, right? Similarly, we can have several other network also coming to be a part of this particular network. Similarly, many other people are also joining to be a part of this particular network, and this way how is your internet keep on growing day by day, day by day, day by day. Okay, this is how internet is actually getting formulated. Okay, now I'll tell you in your home networking what happens. Okay, hope you understood what is the meaning of internet so far now. Any doubts so far with respect to
No,
internet? Uh,
no.
Sneha, do you have any doubt? I want you also to interact. Hmm?
No, Arpit.
No, if you have any
I'm
question,
good.
please let me know. I'm not going to move forward without that.
No, I'm good.
Ria, any doubts so far?
Nothing, Arpit.
If you have guys, if you are having any doubt, stop me there itself. Only. Okay. So what happens normally in your home when you contact with your internet service provider to take internet? So okay, what is happening is they actually install one big box in your home that is also called as a router. Okay, and what they do is this particular router is also called as an internet gateway. This router is also called as an internet gateway. That means this is a public world. So public world, I mean internet. Okay. Whenever I talk public world in the any going future, whenever I talk about public world or internet means the same thing only. Okay. So whenever you contact with the ISP service provider, say company like Jio, or they actually install a box in your home, and what they do is they actually install the router on top of your home, and they actually create one big virtual kind of connection in your home. Okay, and they actually on one more thing before moving to internet, let me talk you about the subnet and the submask. And one the other term that we have is called the masking, network masking. Okay, masking, network masking, we say normally. Okay, what is a subnet and network masking? Okay, so what is happening is the moment when you remember, I told you any number that is a that can be stored within this particular address within the range of 0 to 255 is a valid IP, right? But how would we find out that from this particular IP address, okay, this particular IP, which is this particular IP that we have, is a part of which network, right? So just to take an example from your mobile number. Currently, normally you guys are very much comfortable with your mobile number. Normally, say your mobile number actually starts something like 9431125 720 is one of your contact number of this particular device. So you actually have a SIM card, right? This SIM card actually get assigned with a number. Similarly, this device will also have a number, something starting with this 257. It is a 10 bits number, right? It is normally something a 10 digit number, right? And similarly, device C will also have a SIM card, and it also will have a some kind of a number that you will have. Correct? Now, say any number that actually starts with 94 belongs to Airtel. Okay, so if I have to call any guy, if I have to call any guy who is a part of my Airtel company, okay, so this 94 actually just an example that any number that starts with 94 is a Airtel company's number. Okay, is a Airtel company's number. Okay, so if one of the device wants to communicate with the other device, they will directly call this particular they will directly call on this particular mobile, and they can directly talk with each other, right? If this device want to call, they will call on the SIM card, and they can actually give a call on this number, and they can try to understand, okay, to this any number that starts with 94 is the number of the Airtel company. But what if any number that start with 93470 2567, maybe this number that actually start with 93 can be a part of some different organization, say Geo. It is possible, right? So if these devices have to communicate, they can directly communicate with these particular devices wirelessly. But what if some other company has to actually talk to you? You need some Geo will have their own particular device which will help in connecting their Geo user. But Geo and Airtel currently are two different independent companies. They are two different networks, right? And if two different networks want to talk with each other, we need some kind of an intermittent device, right? Though which will help in establishing the connection between these devices, and all of these devices within this particular network is also talking with each other using some intermittent devices, right? When this number is giving a call to this number, so maybe the connection is getting routed. It's called a route. Maybe the connection is getting a route to in this way. Could be possible, right? Your connection might be getting routed through this number, or through this way, right? Or through this way. There could be some kind of intermittent devices within the Reliance. But what if in the same way in Airtel also there could be possibility, there could be some intermittent device which could be helping in establishing the connection between all of these devices and helping in routing the calls to different devices which are part of your Airtel organization, right? It could be a possibility, right? Now if this number that is any number that we start from 94 that belongs to Airtel company, and if they want to connect with the 93 number which belongs to Reliance, right? So you need some kind of intermittent device which understand both of this particular network, right? So then only the connection can be routed through both of these particular different networks, right? In the same way, when we talk about the mobile number, in the same way, in case of our laptop, we are actually having the IP address, which are unique in nature. Okay. Now, in the same way, we are having the IP address. Okay. And say one of the device. mm, so slowly, I am moving towards sub-masking. How we can understand uh, that my device, which is actually connected to any network, is part of which network? How would we understand this thing, right? For understanding this thing, uh, for understanding this thing, we have something called as this sub-masking. Okay, so if you have to actually find out, or I can let me give an example in this way. So if you have to find out your device, so you can make this screen little shorter. Yeah. Right, there could be a possibility, right, that if you to find out, understand whichever device that you actually want to communicate to, say this is your laptop A and laptop B, and this laptop will A will also have some kind of a IP address, right? In the similar way, this laptop will also have some kind of a IP address, correct? This laptop will also have some kind of a IP address. Now, how will we understand whether this device B and device A are part of which network, right? This device A and device B are part of which particular network, and to establish the connectivity between these two devices, we need some kind of intermittent device which can help in establishing a communication between these two devices. So, how will we understand these two devices are part of which network, right? So, this is actually possible using the subnet masking. That means the first two bit of your IP address we have actually reserved for your network name. Okay, that is 255.255 and point 0.0. This particular number tell me that this particular IP address that you see is a part of one of the network. Is part of one of the network. Okay, and if the first two bits we reserve for this one, okay, we reserve the first two bit we reserve for the network name. Okay, we reserve for the network name. So this identification could be identified that this particular device are part of a which network. So what we do is we mask them. We mask the first two byte as a network name that help me understanding, okay, that this device which is having the IP address of 192.168.1.2 and this device 192.161.1.3 are part of same network. Okay, are part of same network. What if we bring any other device which is actually having the IP address, and this identification of the network is also called as submasking. Okay, where we are actually reserving any out of any 4 bytes, we are actually reserving some byte. Okay, out of that we might reserve 3 bytes or 2 bytes as a network name for you, and the rest of the byte that you see is called as a host name. Okay, and the rest of the byte that you see is called as a host name. Okay, it's called as a host name. So, so what is actually happening is, I hope you understood. So the moment when we talk about the sub-masking, you can, yeah, the moment when we talk about 192.168.0.0, it is the sub-masking which actually help us in the understanding that the first two bit we have actually reserved for the network name, and the rest two bit we have actually reserved for your host name or the host IPs, I can say. So whatever the IP address that we are going to create, we are going to create with the last two digit combination. and the first two digit we are actually reserved for our network name. Okay, in the and this entire process of identifying that my IP address belong to which particular network, just like in my mobile, any number that start with 94 belongs to Airtel company, and any number that belongs to 93 belongs to Reliance company. In the similar way, any IP address whose first two bit is actually so any submask, I can say any net mask which is actually having 255.255 reserved for the network name, we can understand that this particular IP address, okay, is a part of one of the network of this device. Similarly, any other IP address that is 190.168.1.2, if we have reserved the first two bit as a network name, we can understand, okay, this particular device is also belong to the same network, right? And this number that you see over here and the rest of the digit that you are actually having is called the host IPs, from where we are actually giving the IP address of the system. Okay, now if you see in my laptop also currently, so sub-masking, that means I told you that you are when you take out the decimal number of this particular IP address, sorry, when you take out the binary number of this particular IP address, 11111 or 01011111, that means out of few bits of your, out of the 32 bits that you have, 011111.00 or 110 something, total of 32 bits that we have, we are actually reserving the first two your first 16 bit as your network name. Okay, and the rest 16 bit we are actually reserving for assigning the IPs. Okay, in that way we can actually write out of we are writing that first 16 bit as has actually been reserved as your network name, and the rest 62 and rest 16 bit that we have is actually reserved for your IPs, right? So this way also we can represent /16 is called your CIDR range, class inter domain routing. Okay, that means the first 16 bit we have actually reserved for the network name, and the rest 16 bits that we have left out of the 32 bits. Okay, and rest 16 bit reserved out of 32 bits is going to be the part of your, will make up your IPs actually. Okay, hope you understood this concept. And this is also called as your /16 is also called as your CIDR or prefix length, or also called as prefix.
Arpit, is it fine for you if you can just explain it once again?
Sure, sure. Okay, let me to make you more this clear. And why I'm explaining you the IP address more in straight, because when I explain you the CIDR notation, I'm trying to make you slowly understand in an IP address what is the meaning of this one. Let us take an example of an IP address. Okay, that is so when you talk about an IP address 192.168.1.1, so when you convert this particular decimal number into a binary number, so far what have you understood? If you convert this entire big number into a binary number, right? 0 1 1 1 1 1 2 3 4 5 6 7 8. Right, this is just a dummy decimal conversion I'm doing for 192. Okay, 11101111. Okay, dot 0111101107. So how many numbers are there? This first 8 bit is called as 1 byte, correct? And this first and the next 8 bits is your second byte, correct? And this third byte is your 1 byte, right? These 8 bits are your 1 byte, and these 8 bits are your 1 byte, right? And this total together, if you count the total number of bits, it is equal to 32 bits slash 32 bits. Now, out of slash 32 bits, what I'm trying to do, I'm actually trying to divide my bigger, I'm trying to divide my IPs to identify that I'm actually reserving this first 16 bits. First 16 bits. Okay. I'm trying to reserve this first 16 bits as my network name. Okay, similar to I explained you network name, similar to I explained you how will I identify that my 93 belongs to which company or which network I can say, right? So this first 16 bits that you have, I'm actually out of this 32 bit, I'm actually reserving for the what? I'm actually reserving for the network name. So if we represent this number, it could be something as 255.255, correct? And the rest 2 bits that is left actually from here, and the rest 16 bit that is left out of 32, if we subtract 16, how many bits will be left? 16 bits, correct? Aditi, are you understanding this one? That from first 16 bit, if we are reserved for the network name, okay, if we are reserving for the network name, the last 2 bits that we have is actually we are reserving for all the IPs combination, also called as host name or the host IPs or host IPs. Okay, that means the remaining 16 bits that we have, actually we are actually reserving it for our IP addresses. Okay, which are also called as the host names or host IPs or host IPs. Okay, and to identify that any one of our IP address belongs to which network, we are actually doing the masking of that particular network, and this entire process is called as submasking. Okay, and if we try, and out of 16 bit, if we try to subtract, so we can also represent this particular entire number in this format also. That means out of 16 bits, okay, we are actually reserve your 16 bits, your 16 bits as your network name, and the remaining 16 bits that we have, we are out of this 16 bit, the remaining 16 bits we have reserved for our IPs, and this is what is called your CIDR range. That means whatever the IP addresses that now we are going to create from the 16 bits will start something as 192.168.0.1, 0.2, 0.3, 0.5 up to what? 255.255. That means how many combinations can, how many IPs can we create from the this CIDR range? We can create up to 255 into 255, which will come to somewhere around 65,525 something. That means this many number of IPs we can actually launch from this particular whole IP addresses. Okay, where these first two bits we have actually reserved. That means we are first 2 bits we are reserved for our network name. These 2 bits we have reserved for our network name. That means we can network name, which this 2 number will always be fixed. That means we have fixed this number through our masking, that is 255.255. We cannot assign any number from these 2 bytes, right? Whatever the number combinations that we need to make, we need to make from the rest 2 bits only. Okay, so this is your bigger network. This is called your CIDR range, and whatever the IP addresses now you need to create from the rest 2 bytes only. That is, if you try to create the combination from 192.168.0.0/16, okay, which is also called your CIDR range. CIDR range. That means somewhere you can create this kind of combination: 192.168.0.1, 0.2, 0. Yeah, this will be same only. 192.168.0.1, 192.168.0.2, 0.3, 0.4, up to what? 0.255. That means total, I told you, right? In this particular, we have 0 to 255 is the range. You remember I told you 0 to 255, 0 to 255. That means how many combinations we can make? 255.255, correct? If we do 255 into 255, how many devices we can launch in this one? That means 65,200 something number of IPs we can launch. Okay, the combination that will make is 0 to 255. From this combination now 1.1, 1.2, 1.3 up to what? 255. No, sorry, up to 1.255. The next combination will start on 3.1. So up to how many combination we can make? 255 combinations we can make. And the last IP that will be there will be 255. Okay, this entire combinations of IPs we can make. And this is what is actually called your CIDR. Aditi, any conclusion? Now, Aditi, Ria, any conclusion now? The next, any confusion so far? Ria, Aditi, and Sneha. Is there anything that you
No,
didn't understand?
no, Arpit, I am good. Good.
Ria and Sneha, did you understand how we are actually calculating out CIDR range, which is also class inter-domain routing? Okay, and this particular 30, because you already know that this 2-bit I reserve for the network name, and whatever the IP combinations that I'm going to make from this from this leftover bits. Okay, that means 255 dot into 255 combinations we can make. That means around somewhere around 65,255 devices or number of IPs we can launch from in this entire big network of this one, 192.168.0.0/60. Okay, how we make the combination in the similar way. You see my lap. So whenever my Geo guy, when I'm connected to my Wi-Fi currently, right? So they have created one CIDR range and they have actually assigned one of the IP address from this particular range. And 192.168.29.5. So what is the CIDR range of my network currently? Huh? So my network is currently this one. And you see, this is called your subnet masking. That means where we have reserved the first 3 bit as my network name and the rest bit that we have. So whatever the IP combination that will be made from this leftover bit. That means if I take an example of my own device, of my own laptop, of my private network. So what they are doing is can be made bigger or not. So 1 second. Sneha, have you understood? I want an answer from all of you. Don't be on mute over here.
Yes, yes.
No, if you are not understanding, just let me know over here itself. Okay. I'm not going to continue because this is a very important concept. That means you see currently from my devices network, if I see what happened, my Geo company, when they installed my router on top of my home, okay, they have actually reserved my first 3 bytes. Okay. They have actually reserved my first, they have actually they have actually reserved my first 3 bit as my network name. Okay, this is also called as a subnet mask. Okay, you see, this is called subnet mask, right? This is called a subnet mask, right? Where what they are doing is they are actually reserving my first 3 byte as my network name. So when my router was installed in my home, so the network name, my CIDR range that they have given, that means how many number of my devices are can be connected to my particular own private network of my home, which is actually installed by my internet service provider company, was this CIDR combination they have given, that is 29.0/24. That means 32 minus 24 equals to 8. That means 2 to the power 8, if you do, it will come to around how much? 2 to the power 8. 2 to the power is 8 is how much? That means around 256 devices can be currently connected. That means around 256. 256 devices 256 devices can be connected to my network. That means can be connected to my Wi-Fi. Okay. See why? Because I have reserved my first three bit as the network name of now. So you can, if you want more number of devices, you can keep on reducing your submasking. Okay, to add more and more number of devices. Okay, slash 24 reserve how many number out of 32 you have actually reserved for your network name. Okay, and that means over here 32 minus 24. That means 24 bits I have already reserved for my network name, and my 8 bits that are left over I have actually reserved for my host names or host IPs. Why? Because why it is called host IPs? Because it is local to your host. That is the reason why your devices are also called as local host. Okay. And there is an IP address assigned to your local host. That is the reason why sometimes you also give the IP address of your local host. 290.55. This is the local host IP of this is the IP address of my local host. Your could be a different one. So why we call as host name. Okay, tomorrow I'm going to explain you the concept of a. I think we have time. We can explain now. Public IP and private IP. I'm going to so whatever this IP that you are currently seeing in my laptop, this laptop is my private IP. Is my private IP. Okay. Why? Because nobody from the outside world can currently connect to my laptop. Even uh, this is called my public IP. So why it is called as host name, I can say, or host IPs when I was talking about. Why? Because whenever we talk about google.com, right? Google.com, it is also called as a host name icon. It is called as a domain name or a host name. Why? Because this particular google.com, wherever in whichever server it is running, okay, whichever server is running, this server must have been assigned with a kind of a IP address. Okay, this server must have been assigned with a kind of a IP address. So this is a mapping from your IP address to your domain name. Okay, but behind this domain name, there is a public IP that is actually running. There is a public IP that is actually running. Okay, so you can just forget about the word public, just understand the word IPs. Okay, and you can understand, forget about this word private for now. You can understand the meaning of IP. So that is the reason when I was saying this local host means it is local to my particular system as of now. Okay, so that is the reason why it's called 192.168.29.5 is the IP address of my local host. So if anybody say local host in my currently network, if from my device, if I say local host, or if I say 192.168.229.55 points to this local host only. That is the reason if I write this in my browser, if I write this or this, it signifies the same thing. Okay. And how many number of IP addresses can I launch currently? As I already explained you, there could be somewhere around 256 devices that can be currently connected to my Wi-Fi. Okay, there is around 256 IPs I can say can be connected to my network or my Wi-Fi, I can say. I hope you have understood so far. I'm going to explain you what is the meaning of a IP address is of two types. One is a private IP and other is a public IP. Okay, but so far, did you understood the meaning of the term IP addresses and how do we calculate the IP addresses and this particular range? What is a CIDR range? Did you understood what is a CIDR range? Did you understood the meaning of the word CIDR? Because after this, only our next things are going to be dependent on this one. Any questions so far, guys? Before moving to any advanced practical. What is a subnet?
No, Arpit.
Subnet mask. What is a subnet mask? If you want to add more IPs, you can just reduce your number over here. 255 dot this one. You can keep on reducing your subnet masking to add more IPs. That means out of this, uh, normally what you're doing is out of 32, we have just reserved your 255. That means 32 minus 8 would be how much? 24. Okay, that means 2 to the power 24. If you do, we can add more IP addresses in your network, in your bigger network. That means in your bigger network, think your network you have assigned something like 10.0.0.0 slash the moment when we give 24, that means more and more number of combinations you can make. That means 2 to the power 24. If you do, how much it will be? 2 to the power 24, 2 power 24, 2 power 24. How much it is? That means this many number of devices you can currently launch into your network. So the more you actually change your subnet masking, the more number you can make. How much was your number? 16 lakh, 16 lakh 77,216 devices you can launch within this one of the network. Within this one of the network. And you see, again, this number was within the range of 0 to 55. So this number is also a valid IP. You can give any IP address. This was just one random examples I'm giving. But hope you have understood what is the meaning of CIDR range now. And this entire range, slash 24, is called as CIDR. Okay, where my 22, sorry, this will be my slash 8. Not 24, this is my slash 8. Okay. Not 24. No, it was correct one. It was my slash 24. Okay, sorry. This is actually will not be 24. This will be 8 only. Okay. This represent your subnet masking. That how many bits you are reserving for your network bit. Okay. My bad. This will be actually no. This number that you see, okay, will be slash 8. Is how many number can you, if you want to add slash 8. Okay, slash 8. Okay, this represent your CIDR range. This is what is called CIDR range. And this and within this whole big network, within this single big network, within this single big network, how many devices can we actually add within this particular range? If I give this CIDR range, which is also called as class inter domain routing. I hope we understood the meaning of this big network. Big network means one single big network. When we talk about one single big network is also called your CIDR, class inter-domain routing range. So far, any confusion so far? How we are adjusting the subnet masking to increase and decrease the number of IPs. You could also, there is not necessarily, it's always need to be 255 or 255. Okay, you can also reserve something like, if you have given 255 in your subnet masking, but you have reserved 198. Okay, out of 25 minus 198, you can do 25 minus 198. Okay, somewhere it will come to around, if you do the subtraction of 255 minus 198. Will be 47, right? That means 198.0.0. That means out of 0 to 255 combinations, okay, 0 to 255 combination of this particular byte, till 0 to 198, you have actually reserved for your network name. Okay, that means after 198, from 199 onwards, that means 0 to 190 onwards, your IP addresses range will start. Okay, and this CIDR range will automatically change accordingly from 32 bytes. Okay, adjustment will be made. So if you want to increase or decrease the networking subnet masking, so your subnet mask is the one who decide how many IP. So your we can come to the conclusion that your subnet masking actually decide how many IPs actually devise how many IPs how many IPs how many IPs can be assigned, or how many devices can be assigned, how many IPs, or how many host IPs, I can say, how many host IPs can be assigned to one of that big network, I can say. Hope you understood the meaning of the one subnet masking now. Okay, so when I was saying that 250.198, it will come somewhere close to around how much? 57, I can say. Right. So out of this particular byte, 57 bytes are still left that we can add into our host IPs. Okay. So if you calculate out the subnet mask for this one, 198.0.0 slash 32 slash how many will be the combination? These two combinations are 255.255. Okay, which will come to around 255 into 255, it will come to around 65,000. It will come to around my 65,000 to 5 plus out of 255 minus 198 if we do, it will come around 57. So you can add plus 57 more IPs over here. Total will comes to around how much? Plus 57 if you do, that means 65,000 active IPs we can launch in this. If you're masking, if you're just your masking like this, generally these are actually part of networking. When you go for the bigger exams like CCNA or this one like Cisco networking examination, then we go for this kind of combination. But in general layman terms, I can say we don't have to make this many number of adjustments. Generally in the cloud, you can understand for your ease of understanding. I told you thing this much information was not needed so far, but for your ease of understanding, I can told you, okay, this many IPs you can launch currently. Okay, and here you can decide your masking based on that. So this particular combination that which you will have would be, I think, slash 16. So would be slash 16 plus 57 plus 57 would be something if we calculate out the number of 37. This particular part will, there will be some number that will be coming over here, something around we can say 14 or 12 something. I think it will come slash 14 or slash 12. Okay, I'm not sure. I will have to check this calculation. Subnet calculator if you open it. CIDF subnet calculator. Give around. I give my net mask calculator. The different net mask calculator to which you can calculate this with. Actually, that level of calculation we can do. That is not needed, I guess, in for our this one. If you want, you can keep on changing the net masking. You see how this net mask, this network class you see, right? Forget about this ABC. There is nothing called as ABC. If you can keep on changing your net mask, you can actually calculate outcome. Net mask. There is some Subnet calculator that you can actually use. You have to find out how many will be 70. Will be slash 70. If you want to calculate out for exact one, you can keep it 192.55.198. 55.192.0.0. What is the CIDR? What is the CIDR? slash 190. So we are representing this entire number, the prefix length 31 or something. Something it will come. Okay, 0.0, right? It will come in the notation of see the IP address range that will be given. So this one actually number if you want to change, right? There is a way to calculate out what could be your CIDR range that you have to give out of this particular house. Out of 32, how many bytes will be reserved in this case? Where you 65 on this many 50 will be the. We can actually, this will be somewhere around 17 or 13 it will be. Okay, this is just an approximate number that we give. Exact number calculation is not possible in this format when you put it. For now, you can just forget about this. But I hope you understood on a high level what is this particular calculation is made. Okay, you can keep on reducing that number. In next class, I can explain you how this subnet masking be there, but that is actually not needed. But in a layman term, I think you must have understood how these calculations are being made, right? This many number if you have to how you can represent in the slash notation. This part I'll have to check how we can represent it out. Okay, there is a formula which actually helps in calculating it out. Will maybe I explain you in the next slide. But so far you understood, right? What is a CIDR net, what is our net masking, and what is an IP address. This was my agenda of today.